Hi, it's Mr. Estrada, and our learning target is I can prove isosceles, scalene, and right triangles on the coordinate plane. So let's get to it. It says prove that triangle ABC with vertices A 0, 0, B 3, 4, and C 6, 0 is isosceles. Okay, now this is important. Anytime you see that word prove, anytime you see that word prove, when you are asked to prove, you must provide a statement that is backed up with evidence. So, for example, triangle ABC is an isosceles triangle because it has two equal sides, has to be backed up with evidence. So it's not enough to just say it's isosceles triangle. You have to prove it. You have to show evidence. So you have to say something like AB is equal to BC since they are both blank units. And that would be the evidence that you have an isosceles triangle because you have two equal sides. All right, let's get back to our example. So here we are asked to prove that triangle ABC is isosceles. So here is triangle ABC. So remember, I have to write a statement and I have to give evidence. So I have to write a statement and give evidence. So an isosceles triangle has two equal sides. So I must give evidence that triangle ABC has two equal sides. And to do this, I will need the distance formula. So to show that this has two equal sides, I will need to find the distance of AB. I will need to find the distance of BC. And I will need to find the distance of AC. And if you recall, the distance formula, I'll write it up here, is equal to x2 minus x1 squared plus y2 minus y1 squared. So I'm going to go ahead and find the distance right now, and then I'll be back. All right, so there is the work. I went ahead and I applied the distance formula for side AB, and I got a distance of 5, so AB is 5. And then I also applied the distance formula for side BC, and I also got 5 units. So it turns out that side AB is equal to side BC. So AB is equal to BC. So what can I deduce from that? I can deduce that triangle ABC is isosceles because it has two equal sides. AB is equal to BC because they both measure 5 units. And there I'm done with the proof. I proved that it's an isosceles triangle. I wrote a statement and I gave evidence. All this is my evidence that this is an isosceles triangle. All right, let's try another type of proof. Here we are being asked, prove that triangle ABC with vertices. Whoops, I actually have to, let me change those vertices. That's not correct. All right, so there it is. I corrected it. So it says, prove that triangle ABC with vertices A 1, 1, B 5, 5, and C 8, negative 3 is scalene. So we're being asked to prove that this triangle here is scalene. Okay, so now, in a scalene triangle, none of the sides are equal. So to prove this is a scalene triangle, you must show that none of the sides are equal. To do this, you will need to use the distance formula. So you will need to find the distance of AB. You're going to need to find the distance of BC. And you're going to need to find the distance of AC. So let me just pause the video and I'll go ahead and do that. All right, so I went ahead and I found the lengths of each of the sides, or the distances of each of the sides. So AB came out to radical 32. And by the way, feel free to leave these in radical form. You don't even have to simplify them to tell that they're not equal. BC came out to radical 73, and AC came out to radical 65. That says radical 65. Let me rewrite that. So what could we deduce? We could say triangle ABC is scalene because none of the sides are equal. AB is equal to radical 32, BC is equal to radical 73, and AC is equal to radical 65. So that proves it, that settles it, that it's definitely a scalene triangle since none of the sides are equal. For our last example, we are asked to determine or to prove a right triangle. So it says, a triangle has vertices A, B, and C. Determine if the triangle is a right triangle. So even though it doesn't use the word proof, it's implied with the word determine that this is a proof. So let's go over some basic things. A right triangle has a right angle, right? Right. To determine if a triangle has a right angle, we must determine if any of the sides are perpendicular. Because if you have perpendicular sides, then that means that you're going to have a right angle somewhere, because perpendicular lines form right angles. To determine if any of the sides are perpendicular, we must find the slopes of each of the sides and determine if any of the slopes of the sides are negative reciprocals. So for right triangle proofs, we need to find slopes. So what's the slope of AB? So the slope of AB is up 1, 2, 3, 4 over 1, 2, 3, 4. So it's equal to 1 over 1 when you reduce it. What's the slope of BC? The slope of BC is down 1, 2, 3, 4, 5 over 5. So it's negative 1 over 1 when you reduce it. So just from this, you could tell that AB is perpendicular to BC. These are negative reciprocals of each other, so you know that this is a 90-degree angle. So we could write triangle ABC is a right triangle because AB is perpendicular to BC, since the slopes of AB and BC are negative reciprocals. All right, so that settles it. We just showed it's definitely a right triangle because you have perpendicular lines that form a right angle inside the triangle. All right, hope this video helps. Take care.